Alright, differentiation. Let's go. So we're looking at answers for number 1 and number 2 one time. Answers for number 1 and number 2. The gradient of x is equal to pi and 2. The gradient at x is equal to pi and 2 and the curve y is equal to cos x. So this is all the questions that I created here. It's all that I could think of that normally comes to CSEC in terms of differentiation and integration. Those who are doing pure maths, you could take a little look at this as well. It doesn't get nowhere as deep as pure maths, but it has some stuff that you might actually see in unit 1 maths. So notifications now get sent out. Everybody X the live chat and press like. So we're doing practice for multiple choice. All of differentiation and integration. This comprises of how much questions? This is like, I think it's the last 10 questions in your multiple choice. Like from about 35 to 45. You know the maths multiple choice is only 45 questions. And you could use calculator. But there's be some challenging questions in the mix too. But the last 5, I think it's the last 5 and 5. 5 differentiation, 5 integration. And is real repeat. Every year students say the same thing. This grade, they give you a gradient at a point, always some tricks thing, stuff like this, right? So, it be a little theory, sure, no problem. So when you're differentiating, y is equal to ax to the power of n, dy dx would always be an xn minus 1. So an example that you always use is x squared. What happens here? Y is equal to 2x. Right? So this, just with this example, from now y is equal to, I want to say dy dx is equal to. Just from this example, you can immediately figure out the law now. You're losing 1 in the power because the power went from 2 to 1. And this 2 comes down and multiply. The whole power you get multiplied by. So this is the basic for differentiation. Why is in the chat if it vibes back? No. If you have like sine and cosine, you need to know how to differentiate that as well. Forget tan. Tan is sec squared, but you don't need to. Do we do that? Do we get that in? I never see that in, at least I never see that in AdMaths. In AdMaths multiple choice. Never hear about that. See my AdMaths textbook. So so if you have like y is equal to one of these, right? The differential, the dy dx would be equal. When you differentiate sine x, you get cos x. When you differentiate cos x, you get negative sine x. And you must know that inside out, outside in, that is going to be tested for sure. Everybody in this chat, for sure in your exam now. So in your paper 1, this tricks thing will be tested at least in 2 or 3 questions, maybe even 4 questions out of the differentiation and integration will have that in it. Maybe even 5 will have this, knowing this in it. So for example, if you differentiate, you go this way. If you integrate, you go this way. For example, if you had to find the integral of cos x with respect to x, what you do is look at this thing, it's in cos x. So therefore the answer will be equal to sine x plus c, constant of integration, right? If you have to find the integral of sine x with respect to x, it will be, well, you're seeing here sine x goes to cos x, but the sign changes. So if you're finding the integral of sine x, it will be negative cos x with respect to, not with respect to x, plus c. That making sense? Yeah, that making real sense. So that's a little touch, a little glisten on the theory there. So let's go back into this. The gradient at x is equal to pi and 2 on the curve y is equal to cos x is what? So if you want to find the gradient at a curve of a curve, you just need to differentiate the curve and get what we call the gradient function. I have videos on differentiation, I don't know. I doesn't have much theoretical videos on maths. I mean add maths, sorry. I have every theoretical video on maths. I have tricks, the whole of tricks. So y is equal to sine x, right? Or let me just say if y is equal to f of x. I just want to talk about the theory here. So when you differentiate dy dx, you get that, right? What you want to do now is substitute x is equal to whatever, like put a, the constant. Now let me show you some magical tricks out here now. Some magical tricks out here. Didn't I tell you you can use your calculator in add maths? That's not trying to bring it up for you. Come on, boy, you can do it. Okay. So let me discover some magical tricks here. We can get the answer for these 2 questions and even 3 or 4 questions. If I get the time, I could probably make a book for the add maths as well. If not, well, then get the time. It's take real time. It's take real time. So the gradient at this point, I don't know if I'll see the, I really moving my mouse and thing here, but I don't think I'll see that. The gradient at this point for this curve, you can plug that straight into your calculator. You can find shift the gradient. You see this? This is called differentiating at a point. Your calculator designed to crunch numbers. This calculator. So you can say dy dx, and instead of y, just write what y is equal to cos x, cos of x. There's one alpha, so you're going to press alpha and you're pressing x. And all you need to do is press x is equal to pi and 2. Now, you know, just to say x is equal to pi and 2, what does that tell you? We operated in the land of radians. So you want to make sure you calculate in radians. So I'll press shift setup 4 to select radians. And all I need to do is press equal. Alright, maybe not. X is equal to pi on 2. X is equal to pi on 2. Y cos x differentiating, yeah, this will be so. Where's my problem? Where's my problem? I'm gonna try pi and 3 and see something, because this is 90 degrees, eh? This sucks. Where's my syntax error here, by cos? Why leave out? Cos. Oh, I'm missing out of brackets, because this is cos of x. You all see that? Well, you got a little problem solving here. Cos of x. Hey Cassie, hey Dark Magician. So, what happened? This brackets is for the this brackets is for the differential. Why is in the chat if you understand the problem I had here? So I left out the brackets and around this. So let me get rid of this tree. Delete that. Alright, we ready to perform again. Come on, don't do me this time. So you're differentiating in radians is pi and 2. You press equal and you get -1. Answers out in the dance. Anybody have a calculator and plug this in the calculator and try this one time? I just give you the. This is things, as I said, that people, certain select few in the society, knew all along. Years now, people know calculators can do this. Years now, people know quick ways to solve quadratics, differentiation, definite integrals, and the calculator. And only the top boys used to know. Now, everybody, once you watch this channel, you know. So you could actually, yes, you can actually crunch your numbers quick, and your calculator straight up. But even if you didn't know how to do that, what you will do is write dy dx would be equal to negative sine x. And then what we're trying to find, the gradient at pi and 2. So you're going to substitute at x is equal to pi and 2 now, minus sine of pi and 2. And everybody know that sine of 90 degrees is 1. Pi and 2 stands for 90 degrees, right? Sine of pi and 2 is 1, so this is equal to negative 1. So you could do it manually, you could do it on your calculator, look like a boss. I'm so glad I buy this calculator, I get it. Bless. So maybe you're getting the error because you do the same thing I do, you forget to double up on the brackets. Right. Ting. Sharp people, I don't think sharp people in the dance for this. Or they just had to stay out of this dance. Just do this with sharp people. Alright, so the gradient at x is equal to 6. So same thing. So Jared, what's the answer for number 2? D? Somebody saying number 2 is D. So let's use the calculator power again for number 2. So whatever comes in this style of a question, when they're asking you to differentiate a function and they're giving you see from the time they ask you to differentiate a function and they give you the x value of the function, it's all over. It's all over. You have this, you have that. So you're pressing shift and that, right? Now notice you're seeing 2 brackets here. So that's why you need to put in your function. You need to put in your sine x. Sine, open brackets, x. So you're pressing alpha x. Don't forget to close back the brackets. And now you're selecting what value of x you're looking at. So you're looking at the value of, so I'll select fractions here. Pi and 3, right? So shift, real is pi 3 equal. So 0.5 is the answer. So D is the answer. Why is in the chat if you understand the calculator method? Why is in the chat if you understand the other method? Next question. So you do not, it's like about 15 questions and all. If I think of any other thing, I'll come back to it. But I think I'm pretty comprehensive here. I spent a good bit of my last night just working on this for y'all. I hope the 46 of you already appreciate this, because this was some tears. Anyhow, given that y is equal to sine 2x, then dy dx, right? So you can't do this on your calculator. You can't do this on your calculator because you don't have an x value. So the calculator not allowed to differentiate for you and get it. Now, if you need to work to get the answer to a differential or integral home, you can check the website Wolfram Alpha. And you can put this in and it will give you the answer, it will give you the steps, everything. So like if you're revising and you're seeing something that you don't really know how to do, check it. So how you differentiate this? Very simple. You differentiate the sine, you get cos, put back the 2x. And you also need to differentiate what's inside here. The differential of 2x is 2. So you're going to multiply by that. Excuse me. So it's basically the chain rule that's occurring here. So what is the answer for 3? Let me read some comments. So I feel this calculator is key to win. What kind of magic is with this calculator? So how late you going today? We have 15 questions. Where I didn't even get the notification. I want also you're going live at 5. Press like for others like me. Yeah, press X of the live chat and press like on the videos. And buy that. Yeah, so the calculator, check it out on Amazon, but it will take a little time to come to. You could probably buy it and get it within 3 months, 3 weeks, depending on where you are in the Caribbean. So the answer for this is B. Let's get the answer for number 4. Let us get the answer for number 4. So when it's chemistry, I wanted to do chemistry and add math, so physics and add math and everything in one, but I'm just busy with other stuff right now, people. But we will get things done. Farhan, what's up, bro? I'm looking for answers for number 4 right now. Yeah, your sharp calculator can't do this thing, what we just do here. That's why I went down on my knees every month on your saying, get the Casio, get the Casio. But people like, but I'm telling you, it can do powerful things and help you. Just double check your work and thing too. Given that y is equal to that. So when you see square root, you should think a minus x to the power of a half, right? So if we differentiate in that, you know, we're going to drop the power by 1. We're going to end up in the minus a half realm. In the negative a half realm. Because a half take away 1 is negative a half. Because remember, that's how you differentiate the power. It's had to drop by 1. So we drop the power by 1. But you also need to multiply by what's inside the brackets. Differentiate what's inside the brackets and multiply by that. And you also need to divide by the whole power. So this power needs to divide. Let me just remind you. If we had y is equal to 2x cubed, alright, let's say 2x cubed, right? And we differentiate that, we're going to get 6x squared. This will come and multiply by that, and this will drop by 1, right? So similarly, this dropped by 1, a half take away 1 is negative a half. You have to multiply this by what was ever in front there, it had nothing. So, you notice you see no really half here? Alright, there, right. So it's one of these, maybe. So it's a half on the outside here. But also you need to, if there's anything that can different, if there's anything when you, if you can differentiate this and get what's inside the brackets, differentiate it. Because that will come out of the chain rule. This is like a u. Remember when you substitute this for a u and you get du dx. So du dx multiplied. So this is just the shortcut method. That's what I'm showing you. So when you differentiate this, you'll get negative 1. Because this is a constant, this will go to 0. So the differential of negative x is negative 1. So there should be a negative in here as well. Which one doing that? D. 4 is D. D though. We had a lot of C's, but. Nah, it's D. Yeah, the negative. So, why is in the chat if you understand that? Do you want me to go and do the chain rule method? Alright, let me do the chain rule method. So we have y is equal to a minus x to the power of a half. So we're going to say let u be equal to a minus x. So du dx is going to be equal to negative 1. Now I expect now you know how to differentiate basically here, right? Yeah, they're seeing it now. Don't make this mistake in the exam. Look out for this. They always in the exam, I know this, they always bring in a square root to differentiate. The square root of something, always differentiating. Let's be a number here, minus x or something like that. They always bring in the square root of something differentiating. So what you need to do is put it to the power of a half, take away 1 when you're differentiating. But don't forget, if there's like negative x, you'll have to multiply by negative. So anyhow, let me just finish this. And so when you let u equal to thing, is like y is equal to u to the power of a half now. So dy du is equal to a half u to the negative a half. Alright? So this is going to give us dy, this is y, dy dx, which is what you're trying to find. Good handwriting, boy. Handwriting now. I'm finding my thing. Right, half u negative a half multiplied by this du dx, which is negative 1. So this is negative a half, and u to the power of negative a half is like 1 over u to the power of a half. So this is, and we could just merge everything into 1 here. Negative 1 2 square root of a minus x. This a minus x, where that come out from? That, remember, a minus x is u. So when you reach the n is bring it back out. So you see, unleash yourself, brother. Unleash yourself. So cool. So this is the answer here, D. Let me get the next one. Number 5 and 6. Gary. Right. So what are we doing? Number 5 and 6. Boom. Let's get the answers for number 5 and 6. I'm waiting on you all to give me the answers for number 5 and 6. I start check out why is this going on in this chat here. It's not lagging. So waiting on answers for number 5 and 6. A video on differentiation and integration theory. That would take some time. Maybe that I don't have. I'll try. When you're going to do physics, let's see if you can do some physics. Tomorrow you'll do some maths. Let's see if you can do some physics on Monday. 6A. Pressure with this boy. I find people sticking with this boy. I never do this before. I'm lost. Is this the quotient rule? I know this is the quotient rule, but I'm about to do the quotient rule. What going on with all you out here? They're revising. So 5 is C. We can see. And then Tori says C. That's not. Let me just check something. 1 second. Are they revising? Alright, so we differentiating this. Yes, it is the quotient rule. Yes, you will say u is equal to 2 plus 3x. So du would be like 3. And v is equal to x minus 1. So dv will be like 1. Now you hope there's an answer for this. So the quotient rule runs like v du dx minus u dv dx over v squared. Now, I just write du here, but I mean du dx. Du dx. So, are you leaving them there? Alright. So, v du dx minus u dv dx. So, then you just substitute. Now, this comes in your exam. Pay attention on it. This comes in your exam. And so it really allowed me. Alright, that's happening. Let's see some more answers. And what they like to do in this way, yeah, so they'll always have this squared, this squared, this squared, this squared. But some kind of simile is gone here and it's normally boiled down to like one of this or something. So let me see what's going to happen. So v du dx might be a kind of cross multiply thing. So v du dx minus u dv dx. I hope this thing will out. So 3x minus 3. You understand? I take this and I multiply by that. Subtract this. This is the trick here. That subtract sign is going and mess up DC. Subtract 1 by 2 plus 3x. V squared coming here. So that is equal to. Now, it's very important that you realize that this subtract is gonna What's the word, boy? Have some fun with that 2 and have some fun with the 3 as well. That is what's happening. That is the problem that's happening in this question. And they will have an answer waiting for you. Like if you didn't distribute this properly. So let's see. So this is 3x minus 3. Take away 2. Subtract 3x over v squared. That cancels with that. So you really end up with negative 5. Now, the reason I didn't bother to put the v squared is actually this square, right? Because all of them have v squared, so I didn't substitute in the v squared. So negative 5, so the answer, you all see now, or you feeling now, the answer is C. C. So 5 is C. Am I right? What do you say? 5 is C. So what you need to do, get the steps, U, V, differentiate both, substitute in the product rule with the quotient rule, sorry, which you're supposed to memorize. Never cancel off this in the quotient rule. Like if you see 3 here and you see something here to cancel, people just get hyper and cancel off that. Don't do that. That is naughtiness. So yeah, the V by the du dx and the U by the dphi dx, and also watch out for this little negative sign. It's a little naughty. Sometimes you forget to do what you're supposed to do. When are you going to do CSEC paper ones again? But this is CSEC pass paper ones we are practicing, not past papers, they're paper ones, original questions. Given that y is equal to 3x squared plus 2, let's get the answer for 6. Let's get the answer for number 6. I'm going to load it up on a new page. So have you done no coronavirus here, partner? It's not really seeing me. So given that y is equal to 3x squared plus 2 sine. Alright, so you can do this one. 6 is B. Six is B. I just confused with what this person in purple is saying. 3x squared plus 2 sine x, then dy dx is... Alright, so this one is just straight up differentiated thing. So 6x, right? So one of these, and differential of sine is cos, no switching the signs, so 6 is B. Right, so we get a real answer to that one. Right, so I'll ain't scare me anymore. 6 is B. 7 and 8. 7 and 8. Let's get the answer for 7 and 8. Let's do 7 first. Probably I should have just snapped 7 alone. Seven. Boom. Quick question, no fun, I promise. Do these students have to know how to differentiate something like sine AX, or is that only from next year? Yes, they need to know. So like sine of 2x, yeah, we just did that. We did a question on that. This is the kind of question you could get that. They will literally ask you to differentiate something like sine 2x or cos 2x in your exam. Literally. Them questions is like 1 second questions, and you need to understand that those are easy things. 7A, 7B, people getting. Now, the long way to do this question is use the product rule, and this is sine of u and ting, pow. But you could just differentiate the sine x like normal and get cos 2x, whatever, sine 2x like normal, and just multiply by what's the differential of what's inside, like there. That's what the chain rule will be doing ideally, right? So y is equal to f of x has a stationary point at blah. If f double prime of x is this, then that point is what? So to know whether it's a maximum point or minimum point, your test is this is d2y dx squared, right? d2y dx squared, aka the second derivative, is what we use to test the stationary point, right? This is like if you differentiate twice. You get the gradient function and then you get the gradient function of the gradient function. So what happens is if that is positive, it's I really don't know. If it's positive, it's a minimum. If it's negative, it's a maximum. Something so. Let me pretend that's the answer. Alright. So therefore you could really not really think about a line. All you really want is this line. Right? So f thing, substitute the x value into that. That's it. Substitute the x value into that and see if it's positive or negative. So substituting, you'll get negative 3 to the power of 3 minus 26. So this is like negative 27 minus 26. This is negative. So if it's negative, maximum point, B. The rate of change of the rate of change, yes. Any thoughts on whether stats, probability, kinematics? My thought is that it most likely wouldn't come. I don't think it will come. Hasn't been coming ever and ever, and I don't think they make any unannounced changes. More than 0 minimum, less than 0 max, yes. Nice. So everybody good at number 7. Let's get number 8 in the dance. Number 8. I like all the answer any questions now. We gain some production. So let's get with that quotient real question, right? Like I would only see one answer. And that was somebody from like my class who already went through stuff. The specimen paper. Okay. Send me the link to the new syllabus. Send me the link to the new syllabus on Instagram. Because you see, I was hearing a talk last year that it come in and then it didn't come. Then I said in January and I said it talk in June too. No. I said he talked the year before and then I hear not talk a while now. I said he talked in 2018, didn't come, 2019 didn't come. That kind of thing. Okay. So number 8, let me get the answer to number 8. Curve C is graphed from the equation. Alright, so you have a curve and this is the curve. That's what I mean. The x coordinates of the stationary points are dy dx is equal to 0. So you want to differentiate. You're going to get 6x minus 12x, this is squared, minus 18. And you want when this is 0, let's divide everything by 6 one time. X squared minus 2x minus 3. So this is x minus 3, x plus 1. So x is either 1 or 3. Negative 1 and 3. B again. Because either x minus 3 is equal to 0, x is equal to 3, or x plus 1 is equal to 0, x is equal to negative 1. Common question again. All these questions common, the themes of them common. They will give you a curve, you have to differentiate it, you have to put it equal to 0, you'll have to solve a real simple quadratic, like this. Divide by 6, divide whatever. Or you could solve it like this too. Or you can put it in your calculator. Let me show you the calculator one time. You know, I out here to help you in all ways possible. So you want to see how to get this in your calculator? No problem. So you put mode. Oh gosh, I hang up on the person. I wanted to answer and say I was in a class. So yeah, you press, what are we on? What are we doing? Quadratic. Mode, equation is number 5. Number 3 here is the quadratic. Boom. You put in the A, B, and C of the quadratic. So like we say we had the 6, we had the negative 12, and we had negative 18. Press equal, you get the 3, press equal, you get the negative 1, and you're going to get the minimum point if you want that too, and you're going to get the minimum point y value if you want that as well. Right. How do you solve the quadratic without the sum and product method? Well, you could use a calculator. You could use the quadratic formula. You could use the completing the square method. But obviously, you're going to use the sum and product method for this, or your calculator, because it's just real easy. Why would you do anything other than the sum and product method? So this is what I did in the sum and product method. I just, what is a number that multiplies to give you negative 3, but adds to give you negative 2? Two numbers, right? So negative 3 and 1 multiplies to give me negative 3. And negative 3 plus 1 is negative 2. The reason I could put it in here one time is because the coefficient of that is 1. Like if the coefficient of this was 3 or something, I'd have to figure out something else out. Alright, why isn't the chat if everybody good with that? Let's get 6 more questions to go. Alright, we're going into the integration now. Yeah, so that is it. That's what we're getting for differentiation for earlier. I think maybe this year they might train a little rates of change, so I'll try and, but they normally don't really bring anything in rates and change, rates of change. Right, but I'll try and think up of something like based off of the paper 2, like with the paper 2 concept to multiple choice. Let's get the answer for number 9. This video live? Well, yeah. But how you answer that? So what button did you press to get it? Just keep pressing equal. Just keep pressing equal on the calculator. If I press equal again, it will go back to the Hello? Afternoon. I'm in a class right now, a live class. I'm in a live class, so WhatsApp me and I'll get back to you. You know, when you message me. Alright, we'll call back in half an hour. Call back in half an hour. Hello? Yeah, hello. I'm in an online class right now. You could message me on WhatsApp. Yeah, I'll get back to you. Things hot out here. Alright, so answers for 9. I'll get the answers for 9 in the specifies live class. Yes, because you know people, this man don't want to talk to me. This man, people is real quick to think you're on some kind of games with them. So I want to make sure. 9C. So everybody can see. Integrating. Now, don't go and integrate this dry this, so because this cube here gangster in the scene. So you need to integrate like as a block. This will go up to 4. So it's one out of these. And you would end up dividing back by the 4. Because integration works like this, right? Like y is equal to, let me say y is equal to, I don't know why the y is in writing good, but y is right equal to, let me see, x to the power of 3. So what will happen is that you'll get, if you integrate that with respect to x, you're going to get x to the power of 4, and you have to divide by the new power now, because you go up by 1 and then you divide by the thing, right? But the other thing with this, you'll have to multiply by the same thing. You'll have to divide by what's in the brackets. Divide by the differential in the brackets. So if you differentiate this, all this pair. If you differentiate this, you're going to get 2, right? So you're dividing by that 2. So we're dividing by 4 and we're dividing by 2. So it comes like we're dividing by 8. So all them people who are saying C correct, anybody who was touching down with a little D there, Zion, I see you. Mr. Hipplewit, I see you. Nah, not B. Because you're dividing by 4, but you also need to divide by that 2. Because when you differentiate 2x minus 3, right? This is the way I want you to just, my phi's and my he's. Yeah. So this is the way I want you to just think of this very quickly. You're going to get something like this in your exam once again. They're going to ask you to differentiate, integrate. This is like part of the AdMath syllabus. They want to make sure you can keep saying differentiate. Integrate something, and you have something in there. So all you need to do, most likely there's 3 or 2 or something. You just put back that. This will go up by 1. So it will go to 4. If it was 2, it will go to 3. I'm just showing you what to do in case, it won't be the same numbers. And you divide by this new thing. But whatever you differentiate this in your mind, and whatever this differentiates to give you, you're multiplying by that on the underneath here. So it's come like you're dividing by that. So like if this was 3x, you have to divide here by 3 as well. So you'll end up with 12 in the end. Why isn't it chat if you understand that little concept, quick little way of integrating that? Let's get some more integration out here. Number 10. Oh yes. So those of y'all who couldn't buy the maths book because you don't have access to a credit card, there's a new method. Now, you can just WhatsApp me, and if you can do online bank transfers, you're getting through. So, about 10 people WhatsApped me earlier this day, and they got through, and I have people calling now too. So if you want to do this, go through that. You're starting back. I add up cos x minus sin x, differentiate this. Right, so there's no power here. So you can just think of this like as one flat thing. Not differentiate, integrating. What are you going to get? 10 is D says Deepak saying, no, you changed any mind? Yeah, but that's all. I don't even need to say that because they're not going to get anything ridiculous inside them brackets for AdMaths. Nothing extraordinary going to come across in the brackets. Now if you get a nonlinear function, you'll have some x's and things trailing with you too. 10D, 10C. So we're having some arguments with 10. What's going on? We integrating it. So the one thing I remember with trig is that if I have sine x and I differentiate sine x, I'm going to get cos x. That's all I walked into the exam with. And everything else need to come out of that, right? So if I have this and I differentiate that, I'm going to get this. Now watch how we're going to make this work. We integrating, so we're going backwards. So we have cos x and we're going backwards, so we should end up with sin x with one of these. Eliminating, so it's either B or C now. And it's negative sin x and we're going backwards. Now, remember, if I have sin x and I go forward, I get in this. If I have cos x now and I go forward, like y is equal, and I differentiate y is equal to cos x, I differentiate y is equal to cos x. Dy dx is going to be sin x, but the catch now is negative. This is the one that I remember because I know this one is positive, so I just remember this one alone. So you differentiate this, you're getting that. So now if I integrate this, I should get back positive cos x. So the answer is this. So it changes sign. It changes sign. So the answer is C. Yeah, my only dog. Then she say hello. Bless her. And the youth man as well. Number 11. Number 11, we nearly finished. We nearly finished, oh y'all. We nearly finished. Alright, number 11, if y is equal to 2x cubed plus sine x, then integrate y with respect to x equals. So this is just some more small integration for the boys. For the boys, somebody differentiate and it had an answer waiting for you for differentiating. Or you don't go in the exam and bring shame upon me, upon yourself, upon your family, upon your mother, your father, your grandmother, yes, your children of the future, and integrate when you're supposed to differentiate and differentiate when you're supposed to integrate it. Please. Let me just get all the marks in this exam. So this is actually like 10 of the questions here in the exam I totally prepare you for. And if you come back and machine this like in a long session before the AdMaths exam, more preparation again. So you get some revision. Things nice out here on this channel, boy. Things just nice. If I had this channel, boy, when I was going to school. Alright, so y is equal to 2x. So what we integrating again. This is just a way with integration and differentiation at different ways. They can just write it and they want you to know all the notations. At the end of the day, you just trying to figure out what we doing out here. We integrating or we differentiating. A good tip is that the last 5 questions is normally be integration, and the 5 before that is normally be differentiation in your AdMaths paper 1. So 2x cubed, this will go to 4. So it's one out of these two, right? And the 4 will end up dividing. The 4 will end up dividing, so you'll end up with 2 here. Alright, so it's still one out of these two. So just, this is the last test. So we integrating, so you're going back up to cos negative, because the sign had changed. So the answer is E. Well done, chat. All you getting smarter, As the life go along, people, brain cells just developing out here. Neurons connecting to neurons and pathways and all kind of thing. I don't know what I'm talking about, but yeah. All you getting smarter out here, man. Well done. This is how I'm supposed to be writing the answer to these questions. Oh, wrong question. Let's get the next one. What is the area of the region bounded by the curve? I don't know who snapped this question, but they kind of cut off the whole piece there, so let me snap it over for this person. Actually, we could just write a little square on this, just delete that screenshot. So this is a square out here, and the lines y is equal to 0 area of region, curve, so you have some kind of curve, negative x squared, maybe something like this, I don't know, maybe something so. Maybe, we don't care what it is. And the lines y is equal to 0. By the way, the line y is equal to 0 is a fancy way of saying the x-axis. The line x is equal to 0 is a fancy way of saying the y-axis. So it's bounded here, and x is equal to 1. So there is some line here. X is equal to 1, right? Alright, 0, 1. So this is the area we try to find. Right? And we try to find the value of that area. Integrate between x is equal to 1 and x is equal to 0. So you want to use a kind of definite integral kind of vibes there. So it'll be like y is equal to 10 minus 9x squared. So the integral between 0 and 1 of y respect to x is equal to, when you integrate 10, you get 10x. You say 10x, so there's a guy who is this man is 10x man. 10x minus, integrate this, you'll go to 3, and you have to divide by 2. Bam, you get that. We can break this down to 10x. By the way, you can do this on your calculator. You can do this on your calculator. Going. Alright. So you can do this on your calculator, minus 3x cubed. Well, let me do it out first. And this is between the limits 0 and 1. So I don't need to put 0 in here because 0 just go to 0. So I can just put 1 and that will be the answer. So 10 by 1 minus 3 by 1. So the answer is 7. Right? A, 7. 12A. Deepak get A, Kedan get A, Tori get A, Mikhail get A. So all the brilliant people saying A. So you can do this in your head? Yeah, you can do it in your head. I mean, right? But calculator, show you how to do it on your calculator. We integrating, right? So you're going to be now like the integral. Hey, come out of that brother. Go back in computation mode. The integral of 10 minus 9x squared. Alpha is x squared between the limits 0 and 1. And that is it. That is it. 7. Calculator. Answer. Straight. You're going to get 2 questions like this in your exam. You definitely should get 2 definite integral questions in your exam that you can just rip off on your calculator if you understand how to write it in. Why is in the chat if all you're good with that? But it must be a special style of calculator. Alright. Let's get number 13. We're looking for number 13. Oh, so number 13 is the volume thing. Because questions on volume require like 2 skills, you know. It's be hard for them to bring a question on volume. And if they do, it'll be a question like this, where they don't give you the answer, because that's kind of asking a little too much. So they'll give you like the function that you'll use, the formula that you'll use. So that calculator allowed? Yes. That calculator is allowed in AdMaths paper 1. How much times? I have a whole video on this that I did last year before exams. Yes, this calculator is allowed. It is not a programmable calculator, it's a scientific calculator. If you're skeptical, work with this calculator and your other calculator. So if they say, nah, that calculator ain't get allowed, you just use your other calculator. But this calculator is allowed. Even this one. This is the updated version of it. People have been using this for decades. The grey one. For decades. Not decades, but over a decade. Those Casios that could do, that could crunch integration and differentiation. The curve y is equal to x squared and the lines. That's so you're integrating between the limits and you're multiplying by pi. And you're squaring. Hey, one of this is supposed to be 4. They have no answer here. I'm supposed to put. Oh, all of them is the same. This is probably the earlier version of the file. What's up when I doing the question? When I do the question, I copy and paste to avoid writing the functions over and over and over and over and over and over and over. But that's so funny. Imagine if you're going to an exam and you see 4 same questions. They'll be like, damn, they just out for me this rocks, man. Yeah, all are the same here as well. I didn't even update it here. So 0. So one of them is supposed to be 4, and they'll leave one just as. They'll leave one without the pi. And what is the next thing they'll do? Or they leave one without the pi and put back the 4. Understand what I'm saying? So they might do one without the pi and put 4 here. Then they do one without the pi. Then they'll do one like that, and then they'll do one with the 4. Like so, in this case, the answer will be D. But I do the opposite way in the here, so it will be E. You understand what? Why is in the chat if you understand that? And I just showing you like how a teacher would think here to create the question as well. Minimize that. You would have to give me a mark. Now the answer is D. Now what really going on in this question? You have to square. So like you have x squared here, that needs to square as well. And you're going between the limits 1 to 2, and then you're multiplying that by pi. So x squared squared is x to the power 4. These kind of questions is a common, like if they bring in volume, if they bring a question for your own volume, yeah, so you square it first, and then you integrate, right? So if they bring a question for your volume, they generally wouldn't ask you to do the whole question. They're now wicked. That's like 2 skills, you understand? That's 2 marks, and each question is 1 mark. So they will bring the question like something like this, where they will give you the answer in terms of a formula or a function or something. Right? So just for those who say explain again in the chat. Like if you have y is equal to x, if you need to find the area, it'll be between a and b, x squared, and you multiply by pi. But in this case, it was y is equal to x squared. So it's x squared squared. X squared squared is x to the power 4. So that's why I need to look carefully at what they have here. Or like if they had x plus 1, or x squared plus 1, the answer will be x squared plus 1 to b squared. And you can actually work out that and get what is and in a linear way, and then alright, that's enough explanation, and I'll get the next question. Second, the last question to do. So the next thing you can do is ask you like to figure out the missing limit. The missing upper limit or the missing lower limit. So I choose upper limit here. The missing upper limit. The value of the upper limit P. The value of the upper limit P. This was talking about consumer arithmetic. Search consumer arithmetic Kerwin Springer online. The value of the upper limit P for which that is equal to that is what? So you understand? They gave you the answer as if this was put in already, but now they're asking to find back what that could be. So the best way I think to do this is to integrate this, right? Don't forget when you integrate that 2, you'll get to 2x, right? Let me see if I get some answers, and they give me some answers. And then substitute. Well, this wherever you substitute here should give you not 0, 3. So you need to see which one of the best way to do this to me is to see which one of these answers will give you 3. It's not 1. 8 and 3 not looking good. It's not 2. 9 will be too much. So you're looking like a C as for them. Now we try this. Equal 3 cubed is 27 over 3 minus 6. 27 over 3, 9. 9 minus 6 is 3. So yeah. So the answer is C. You understand? So you integrate this, equate it to that, and just use substitution of the answers. This is one of the hacks for maths, is to substitute the answers into the question and see if it works. So I will just try 1, try 2, and you can do it in your mind to like 1 cube, 1, a third minus 2. That's not working. That's how I know it wasn't working. And 2 cube, like I take the 2 and I try to put it there. 2 cube is 8, and from the time I hear 8, I know I'm going to end up with a fraction because 3 into, you know, and I have to get a whole number 3. So that's why I feel like 3 would be the best one. 9 is too big. Last question. So this is the last question, and you would have covered all of differentiation and integration. Anybody else here from start to finish? I know we have some silent people watching here, because out of the 40, 50 of you all that were watching for the whole time, we only had like about 20 voice of us people, so there's a silent crowd in the background lurking, just taking down notes. Shout out to the silent crew. I need to make up a name for the silent crew. Is that the name for the silent crew? Silent crew, are you okay with that name? You can't say because you are the silent crew. Alright, so you'll get a question like this, A, C, B. Now when students send me this question, it's be a little confusing sometimes, because sometimes, like, I think this limit will be switched around, or this will be switched around. This is just a question to test if you understand how limits work. Like if you have a limit, like if you have the curve here, like this, right? And again, between A and B, remember, you'll substitute B and take it away when you substitute A. So it'll be like B minus A when you after you integrate now. But what will happen now if you squeeze in a limit in the middle, C? That's what they're trying to do. Right, now pay attention to this. Next thing they do this the opposite way. Next thing they do this the opposite way. Just keep your mind open and make sure you know how to handle it out. Just join us watching our videos. Vanessa, what's up? Anthony, Coffee, Truman, Zakima, yes sir, right here. Yes sir, right here. I only get silent when I realize I need to revise. Facts. 15, we getting B, we getting C, we getting D. Alright, so if you're doing this, you would need to like get the area of this and add it to the area of, let me say, this side. So this area plus this area. That's how I would think of it, and that's what I would be looking out for. So the area from A to C. Because remember, I'm saying that C is bigger than A, but it's less than B. C is bigger than A, but it's less than B. So therefore, C has to be the one that's lying in the middle. So I'll be doing A to C plus C to B. A to C plus C to B. So in this case, the answer will be B. In this case, the answer is B. But just look out for this question, right? Because every time, like I talked last year, I was talking to a student, I think this question, something like this come last year, and like it was vice versa or wrong side or some kind of thing. So just look out for that and make sure you, alright, for example, what I'm really trying to say, like if this is B and this is A, well then this could be B and this could be A, and you would know how to you would know which one to pick. You don't really have one for like that, but you'll know which one to pick based on how it's arranged, right? So just keep your mind open for that. Alright people, it was nice. It was nice. So what topic all I want to do tomorrow? So we just did the whole of calculus, which is differentiation and integration. What topic all I want to do in advanced tomorrow? How long does it take? Let's take an hour. Let's take an hour. Now when I went through the crash course with this, I take a good while of this because like I explained each topic and I went through it and thing. Now I'm just kind of breezing it because I expect you to do your own revision in certain areas. The topic you can look at, but all the questions in logs, all the questions in logs. Logs indices, well, I'll lump it under one. Logs indices, surds. What's the next thing? Logs indices, surds. I might even throw in some functions, maybe some remainder term and thing too. Actually, sharp on the logs. Right. So a log session. So everybody say logs. Everybody want to drop them logs. Alright, people. Logs tomorrow. Bless up. Blessings, my brother. Stay safe. Oh, by the way, if you're one who have never taken a screenshot, take a screenshot now. Post it, say at Maxini, dance or whatever, I don't know. And let people know. Zaikima, bless up. Antonio, Dark Magician, Savage, Danny Griffith, Mikhail Morris, Justin Mahaber. On behalf of the silent crew, it was nice. Took some good notes. Justin! Shout out to the silent crew. Yeah, we getting some keep in the dance later on. Hey, them people will start to pull me back just now. So